What's up, guys? Welcome back to our YouTube channel, and look at us. We got like 4 uploads in a row, and today we're going to try to get up to date. So happy new year. I think this video is going to come out after the new year, and we're going to be giving you a quick update on the 3 valve. Last time you saw the 2 front end. I think you guys saw the wiring coming out of it, and we're making some pretty good progress over the last few days. Let's show you. So we got the engine actually in the car. Now we decided to go with Team Z motor plates. So this video, I just want to get you guys caught up to speed, and I'm going to show you some TIG welding on the headers. I already did most of the hard work, which just requires a calibrated eyeball and a couple fancy tools that we've recently acquired to cut those and make those. But I will show you. I did see Rich Woodward post, or is it Woodrich? I think it's Woodrich, yeah. Post about who's crazy enough to make their own turbo headers in their garage. And yes, I know we are a shop, but that is the first set of headers I made, and it is with a Amazon welder that you could for sure afford on your own, and about 1 year of serious TIG welding practice. So it's all very doable. But let's get into the motor and everything that we've done to the front. Obviously, you guys saw the 2 front end that's done. We now have hood pins on it. We kind of finished the reinforcement of the headlights, mounting locations for the headlights. This is all made. We did switch over to all Team Z front suspension, being that we're a dealer for them, and we wanted to get rid of the stock control arms that weighed a lot. So this one has a much smaller joint in the rear, so it saves a lot of weight. And then obviously being tubular chromoly, it's a lot lighter than the I-beam steel stuff, the cast steel that they use. So that probably shedded some weight. We still have the old shocks in here. This is temporary, but that's a steel body shock, so we'll be saving some weight by switching to an aluminum body shock. We did utilize the Team Z motor plates. They were a little bit more of a pain than anticipated, mainly because we had to trim for the timing cover on the 3 valve. That was one problem. Second is that they were wider than the S197 frame rails, so it was a little bit difficult. But conveniently, the Rock Solid Motorsports kit and the motor plates kind of ended up in the same spot. Now, we're not done with this. This is just so we can get this thing in here and start making the turbo headers. You'll see that's only about 1.5 inches of welding here, about 2 inches on the side. We're going to like box this into here, and then we're going to put some triangle gussets on the back side to make sure that that motor plate location is super, super strong. As of right now, it's just enough to hold this thing in here. The mid plates in there, that required a lot of trimming. So you see there's now only 1 bolt hole location. There was 2. But our goal with this car is to try to move, first of all, lose a bunch of weight, but second, move all the weight to the back as much as possible. I'd rather have a 50-50 or a 52-48 weight bias and then be able to move weight around to where we need it to react differently on different tracks. We did go to the Flaming River manual rack, along with the Team Z front, obviously. And I think that's it for all the new shiny goodies on it. Powder-coated valve covers, timing cover, oil pan. The trans and engine are both on it. And we ended up moving the engine back 2 inches. It's like 2 1/4. So we did get a ton of space freed up in the front. Obviously, all that moves weight towards the rear, so that's good. And then we also moved it down almost 2 inches. So we have a lot more clearance everywhere. The oil pan is about even. You guys can see. It's about flush with the K-member. So it all worked out pretty good. Still a lot of clearance having that Flaming River rack. It's far less bulky than the aftermarket one. After going through a bunch of data logs on this car, we saw that the alternator was not keeping up as the days went on. We literally looked pass after pass after pass, and like mid-season or towards the end, when we really started actually getting after it with the car, turning the RPM a little bit higher, putting the boost higher, the voltage was starting to become a problem. And then after one day, then it was just basically, it would idle, charge, about to 3,500 it would charge, then after that the alternator wasn't even charging. So that was just another factor that led to its demise. And we looked at some pictures of it, and the belt wrap on the alternator wasn't very good. So a couple things we're going to do. One, make sure that we know that we're not overspinning the shit out of it, because that's probably what killed it. 2, make sure that we can spin the alternator, because there was a ton of belt dust on the front of the alternator, like it was slipping. So we switched from a standard electric water pump to one with an idler. And what that's going to allow us to do is we're still going to be able to run our tensioner. We're still going to have an idler here, but it's going to come up off the alternator and then wrap back around and then come down to the crankshaft. So only the belt is really only going to be in this area, and it's just really a crank, tensioner, and then water pump idler. So and the alternator, of course. So we literally just have a series of idlers and tensioners to drive the alternator, and that's all that's going to be on this thing. So that'll work out a lot better, and then we're getting the alternator rebuilt, a little bit beefed up, powder coated black, and that will go back on here just fine. We have to get intake gaskets and things like that. This is now the issue with the engine location. So from like that little bump in the firewall all the way over to like here needs to be cut out, and because it hits like right here. So we'll probably end up like taking it up, maybe even up to this crack, and then back to here, and then modifying that. Because there's about a 1/2 inch of interference with the intake to the firewall right there. So we got to move that back. Otherwise, it's going to be pretty serviceable. We ordered the Maven turbo mounts. We ordered Maven coil mounts. So we're going to figure out where we want to put that stuff. That's going to keep it clean. The valve covers can come off easily. Not that they really need to, but before it had the coils mounted up on top. And just to pull a spark plug and a wire, you had to pull like the whole apparatus off. It looked cool, but it wasn't very service friendly. So we're going to change that with those Maven mounts. This actually does center the engine in the car. So we had really tight clearance on the tunnel on the passenger side. So we had to massage that all over, and that fits okay. It needs to get some paint work done. I still got to put the tabs on for the mid plate. So this will be coming in and out a couple more times. In fact, all the gaskets aren't even really on these covers. They're all bolted down just to keep dust and stuff out of them, but they're not really complete yet. So let's move on to the biggest part of this project recently, which has been what the motor plates caused. The motor plates caused headaches. The old turbo headers would literally come out if we were to try to use them, which that was the original goal. The old turbo header came out right here, and it was a 3-inch opening. So I mean, it was literally this whole section right here and this whole section right here. You would have like a 1/4 inch right here that it would fit under. Obviously that wasn't going to work. So we were voicing a couple different ideas. One was buying different motor plates from Jegs and like cutting holes into them and then finagling the header in and out of it. We already bought these and started modifying them, and they're cheaper than the Jeg stuff is, and I think it looked a little bit nicer. At that point we didn't realize how much we were going to have to modify them for the timing cover, but it did definitely look nicer. So we decided to stick with these, and I wanted the challenge of building new turbo headers out of stainless rather than mild steel. And we wanted some more symmetry. So here is where it is so far. If you follow us on Instagram, you've already seen the passenger side posted. I'll show you guys. This one's all done. It's actually got a gasket on it and everything. It's not fully torqued down, but it's tight to where it was starting to crush the gasket, so I can get some good idea of where it's going to sit. Turned out really nice. I learned a lot. I don't really like this collector style. This is it's just around the outside, and then you have a diamond to put in the middle. But in filling all these spots, like the corner on the outside around, that was not very fun to do. I do not like the quality of how that came out, but it was done while it was being back purged. So, I mean, everything's pretty clean on the inside. It's just not as aesthetically pleasing as the rest of the tubes are. That turned out pretty good, and the flange welds turned out really good. So I'm happy with this side. I think if I was to do it again, I would have orientated the 3 and 4 tubes a little bit differently. I did this one totally outside the car. So I just basically just said, I'm just going to keep it tight to the engine as well as I can. As you can see, that worked out pretty good. But knowing what I know after doing this side, I probably should have started the design in the car and then worked my way outside the car. So this one, you can kind of see it starting. This was both sides. I started with the front primary and then worked my way back. And really, if you're going to build your own turbo headers, the biggest thing you need is an imagination. You have to be able to imagine where these tubes need to go, not only for clearance, but for sizing, and how they're all going to tie into each other at the end. You can't just make 3 and then have no idea where number 4 is going to go, because it makes it really tough. I like that. So on this side, obviously, the main difference and the reason why I didn't build it outside the car is because I wanted to clear the steering shaft. That's another new product. That's just this is a motion column, and we have motions quick release. You can see through the window. So that's all installed. But you have to kind of be able to eyeball these angles. Now I haven't figured out the easiest way to measure for the angle that it needs in a surefire method. Meaning, boom, measure it, you know exactly what it is, cut it, sand it, and then put it on. I haven't figured that out yet, but I am getting pretty quick at the old eyeball method, which is, you know, I kind of have a handful of bends. At this point I've used most of them, but you can see some of the scrap bends I got on the floor around the bandsaw. And you kind of use that and see if it needs to be a little bit longer, a little bit shorter. Then you kind of have that, and then you're taping it all together and, you know, using, okay, it needs a 1-inch straight piece here in order for those two ends to line up and it to be seated in the flange. And then you kind of go from there. And then you have to locate your collector. So how I did it was I built the number 1 tube to my rough collector location. And then once I had that set, that got the most amount of tack welds, because I want this to be in its closest location. So you can see I kept it as symmetrical as possible. I need to lift it up a little bit when I actually do the final welding. But they're flat with each other. They're flat with each other this way, and they're level with each other in the final spot. You can almost kind of see if you compare it to this crossbar, how even they are. Now you can tell the motor plate, this side is shorter because the engine is moved. Normally factory cars, the engine is sitting offset towards the driver's side. When you motor plate this, they offset it back the other way to put the engine center line right down the middle of the car. So I only had so much room that I can make the headers even with each other off the aftermarket, well, what we're going to call the frame rail. But they're pretty close. They're within 1/4 of an inch of each other, because I want the turbo system from here to be very symmetrical when I put the turbos up in this area here-ish. I want that to be the same. I want to be able to put the wastegate somewhere where it's compact, which I think is probably going to end up over here. Might end up right here, but I think it's going to end up over here. I think we're going to end up putting the intercoolers down flat here, and then coming up to the middle. We got a shit ton of room for radiator and air to water to sit in the engine bay here, so we'll be doing that. But back to the headers. That is the goal, right? Then you just start the next tube. So here was my next tube. That last little 3/16 of an inch is just the straight piece I needed to get into the collector. But otherwise, you know, I kind of could get an idea that if that piece ended up straight and that piece ended up at like a 45-degree angle, that was getting pretty close to where it was going to need to be. You can see that I had this tacked into the flange at one point. So as you're going along, and you can see that, you know, mistakes get made. So this one, it seems to be that you slide it into the collector first, because you can go a little bit extra. Then once it's slid into the collector, you can kind of rotate it to where you need to be. Get it back. Sorry, I'm trying to do this through the camera at the same time. Oh, this is the wrong spot. I'll go down one. Number 2. There we go. Perfect. Fits there. Fits there. You can see where the diamond in the middle is going to come into play pretty soon. Then I can leave it. It'll sit and stay as long as I don't bump it. And there was tube number 2. Number 3 was next. Number 3, we did 1, 2, and then 3. Same thing. This one, I know, see now looking at this, that I started from the beginning, making sure that I'm going to have clearance for number 4 to come over that steering shaft. You can see how I kicked number 2 in, and then number 3 is even more so. Let me get this bad boy in there. Boom. All right, so there's number 3. I try to keep these as parallel as possible. You know, making them from scratch, it's pretty hard to do, but. So now, once again, I try to kick that 3rd one in as much as I could, so I can try to keep the 4th one tight to the motor and out of the way of the steering shaft. Now, once we had number 3 in, we had number 1 and 2 or number 1 and 3 looked like they do right now. But number 2, I had originally thought that I was going to try to tuck number 3 under the motor more. So number 2 went way under the motor and then came back to this location. So I had like a big, now this had plenty of clearance like this. So then this one looked out of place. So then we decided to actually take that tube out and then redo this one. So it will look a little more parallel, although once you have the 4th tube in there, you know, it's really just us being picky. Because here's the 4th tube. There she is. Perfect. So there you have it. So now the next step, now the other side, as I put it together, I was tacking it to the collector and I was tacking it to the flange. And then once I was done, I had to take the whole thing off, cut all the tacks, which wasn't difficult because I only did a couple. And then I would plug both sides, back purge each individual tube, weld it up, and then once it cooled, basically reassemble it onto the motor again. Putting everything in the collector, making sure the collector sits how I want it, which is, at this point, it's going to be the same. I managed to make tubes 2, 3, and 4 without really I tacked them to like mock them up, but then over the process I ended up just leaving them untacked and just sliding them into the flange like this. Like you see 2, 3, and 4, we're able to just slide in and out. So that's going to allow me to take it all apart easier. I'll get 2, 3, and 4 done, and then I'll worry about taking 1 off. And then basically what you got to do, back purge, do the tubes, leave the flange bolted on, put the tubes back in the flange, make sure that the collector is going to end up where you want, and then start tacking the tubes together at the collector side is what I did. So what I could take the collector back off and basically weld like the cross, all 4 of them together, put the diamond in the middle, weld that, and then they're still kind of loose into the flange, and then I'll start tacking them to the flange and then tack the collector on and then fully weld both sides. So I'm going to show you guys the finished work on that. This is kind of going to be a long video, but I will try to time lapse some of that to show you how to finish it, although I did not show you the bits and pieces. And then I'll give you a quick tools tip here. 1, bandsaw, lifesaver. It's expensive, but could not do this project without it. This is from Harbor Freight. It's like $1,500 or something like that. Definitely worth it. It cuts really well, especially once you dial in the clamp degree radius. 2, you guys might have seen this elsewhere on the internet, is this Tycon and Sequence Manufacturing radius tube cutter. So I actually have had the other one for quite some time for doing custom exhaust work. This is the 2.5, 3, 3.5 inch model, I believe. And now this is the 1.5, 2, and I forget the other size. But it has 2 different radiuses. I actually think that I have the wrong one. I don't think this one actually does 1 3/4. They told me it did. And I could get it to clamp in there, and using my eyeball, I can get it to cut on tangent. But it doesn't clamp as nice as like a 3-inch one does in this 3-inch one. You know, this really holds it, you know, to put the end of it flat up against the blade. Where this one, I feel like I'm setting it back in the bandsaw to get it on tangent. So I don't think it's working as proper. I have not emailed them because I was just in a hurry to use it. So I'll keep it, I'll add it to the list. It's an expensive tool, but obviously I'm gonna be doing it more and more and more, so it makes sense for me to keep it. I just wanna make sure that I get the one that does do 1 3/4, because 1 3/4 to 2.5 is the most common header size for turbo stuff. And that's what we decided to do here, 1 3/4 to 2.5. And then that allows us our sanitary bends to be nice and tight. Instead of having 3-inch, which is huge and heavy, it only needs this. And this will go up to here, to like here, and then to here. And the turbo will probably end up somewhere like that. All right, I'm gonna yank these tubes off. We're gonna start back purging, and I'll set up the camera so you guys can see the rest of the welding. All right, so this is the last time you see my face for a while, but so we went to PRI. We'll show you guys what we're welding with. A lot of high-tech stuff today. Aluminum foil on both sides with a little itty-bitty pinhole inside on both. Our argon setup, you might be able to see in the background here. We have a split regulator, so one side is for my back purge tube, and then the other side is obviously for the machine itself. After going to PRI, we decided to step up the argon coverage with a BBW14, and this is Michael Furik's new plastic cup. So I like it so far. I like working with it. It hasn't shown any kind of melting. It does use a ton of argon. It wants to be at around 35, and in tight spots, I've had to reach out like crazy like this to get it out into areas, and I've turned it up to about 40, and it welds just like this, like the inside of the header flange and everything, as well as it does anywhere else. So pretty crazy. It's really nice in your hand if you like to weld like this, which I do when doing the bench work. So anyway, we're gonna hop right into it. I have the second primary tube here, no particular order, or number 3, I should say. And I'm gonna go around it. What I wanna do first is make sure that it's tacked in 4 opposite locations. That'll minimize any pulling. The fit up on this piece is pretty nice. I did not chamfer it, so I will be a little bit hotter to make sure I get good penetration. But I don't have any gaps in it. So I'm gonna put the tacks on it all the way around. That'll make sure that it won't pull weird. And then I will start at one end and basically just work my way to the other end. That's how I've been doing it, and that's how it works for me. So obviously constantly learning, don't take it as gospel. And if you have any input on how I weld, I'm curious to hear it in the comments down below. All right, let's get started. This will be the motivation I need to order the Purge plugs from TIG Aesthetics, which we considered doing last night, but just with the time I just spent messing around to do that, makes me feel better about ordering. All right, so I took just a piece of aluminum welding wire, wrapped it around the end to hold my stuff on, so everything's so small. And then I have a clamp. I'm gonna use just one of these magnet clamps to hold my Purge wire. I should say Purge line, not Purge wire. Maybe I use 2 of them. Gotta lock them together. Oh yeah, she's good. All right, so we got the line solid. Now we got the piece. Alright, I always pull this out before I touch it. This is going to be kind of warm, but I'll try to show you guys some of the first ones. So, just getting warmed up for the day. Not bad. Kind of got a little hot on the top of that one. You can see the color. I lifted the gas off too early. That's really like the colors that I want on that last piece there by my thumb. You know, or golder, you know. The color is dictated by at what temperature you remove the argon coverage. So, you know, if you have it flow for a long time, it turns silver, just like regular stainless will. And then anything less is like gold, red, blue, purple. And those are all hotter temperatures that you let go. And then when it's gray, it was way too hot. All right, then my best practice is that when I do that side, I try to flip it 180 for the next round of it. And this one looks like it's going to hold itself up pretty good right there, so I won't really need too much help with the magnets aside from helping it slide. With a little more heat, I'm going to increase the post flow, try to get that purple color. I don't know if you guys can see it yet, but real dark because it was real hot. It was almost a little too hot. It was starting to lose the shape of the puddle, flattening out. I struggle with rotating my wrist as I go. I really got to focus on that. Bam, just like that. We are getting along there. All the tubes fully welded. Camera died for a while there, so I kind of lost you guys, but we got all the tubes on it, fully welded. I just got the first collector end done. You guys can kind of see the rest of it. Pretty good. I'd say a solid 6, 7 out of 10, which is where I rate myself. I like it. I got the diamond in the end. This is rough. Doing this is pretty difficult because it's all thin and then you gotta fill a lot. All the tubes are pretty much in there flush except for this last one. I cheated it out to get it to line up better down here. But otherwise it's doing pretty well. Like I said, I just did the first flange, so I'm working my way down the flanges now. And back purging as I go. You can see that there's no sugary inside to that. It's hard to see, but you just see a smooth weld in there. Unlike some of the black sugaring you see here where there was no back purge. Now it really matters only where it's going to be structural the most, so where it's all filled, I'm not too worried about it around this diamond area, but that's why we ensure that all this is all back purged and the flanges are back purged, and then I actually weld the inside too when I'm all done. So it's pretty strong. Although we're building this turbo setup to be a floating header design, meaning that there's nothing that's going to be supported by the header aside from the header itself. As soon as the V-band's on here, it's going to go to a bellow, and then the turbo is going to be solid mounted on the frame rail. So this literally should not have any weight. It's just going to have heat deformation, which should lead to the least amount of repair work on these, if any at all. If all goes well, there won't be any repair work on them. Hopefully I could ceramic coat them and be done. Anyway, all right, I'm gonna knock out another flange and you guys wanna watch. Argon is actually heavier than air. So normally you see I'm capping both sides. Since this is falling down to an end, I'm plugging the end with just some tin foil. I'm gonna put on here like this. Kind of wrap it up around the edges so it sits on there tight. Make sure to keep it away from your weld because it'll melt the aluminum right into it. And you just see floating debris in there and wonder what that is. It's aluminum. So that's that. That seals it pretty well. Then I'm flowing it at 15, and I actually just put it in this tube because it's all that tube, and the argon is going to fill this tube from the bottom up. And it's just going to end up coming out the top here. And just for my own imagination, really, I'm taking a little piece that I was using earlier, and I'm just capping this plug up here a little bit, but it's really not that necessary. The argon's going to be sitting down there, and it's going to work its way up. Capping this, I don't think really does a whole lot in this part because I'm not moving it around. If I'm moving it around, then you want to keep it capped because then it kind of keeps that argon inside of it like a sealed container. I switched the cup to try to get into the smaller areas. I switched over to my daily, which is the Fupa 12. Another Fira cup. It's really dirty because I use it all the time. Still got it's still gas lens, a little bit less tungsten stick out, a little bit less gas flow. You can see here I actually just had to stick it out really far. That's why it is kind of colored blue there on the end because it was out of the gas coverage zone. So clean that up and then get to work here. Alright, so hopefully you guys have seen enough updates on the 3-valve that you're interested in to see where the heck this project is going. So if you haven't done so already, make sure you hit subscribe down below. But you saw some welding today, which I shared with you. Like I said, I am an amateur, but I'm getting pretty happy. First set of turbo headers are now in the books. They're not 100% absolutely perfect, but constant self-criticism is how we improve. So there is a bunch of things that I learned once again. I don't even want to point out the main flaw, but I'm going to share with you the things that I learned by building these headers. Number one is that I thought I had these collectors dead nuts. I tacked them in 4 places, and even though I did that, it still pulled quite a bit because of the huge gaps that we need to fill with these, I'm going to say, because there's a bunch of material added, and it pulled it inward. So it's a couple degrees off of this one. That really pisses me off because I really was trying to get them to be really close to identical. Will it matter? No. I'm going to have the bellow on here. It's going to be fine. You're not even going to notice it aside from the fact that I pointed it out to you, so you might look for it. It's close enough where it's going to be really symmetrical. Both of them are still going to go over these bars and clear, and I think now I've decided that when we do the flip around here to come around, I'm going to put like that motion thing like off that U and then have the wastegate here, and then I'll have the wastegate continue to wherever the downpipe goes from there. I think that'll work out pretty good. But those are in. Other thing I learned, kind of build them both in the car a little bit, even though that's a pain in the ass, because I feel that this would have been a little bit better or orientated a different way. I don't think it's going to really hinder performance at all because I don't really think the turbo cares that much. But that, and then I got to figure out a way to measure because I don't like this bump on this primary. So I think I kind of put this in there thinking that I was going to move all this over, and I thought this was going to be tighter to there, and really didn't need to be. So is it good? Yes, it's good. Does it work? Yes, it's going to work, and they look really good. I'm happy with the weld quality. I'm happy with the back purging. I'm happy with the clearance on everything. I'm just critiquing myself, so it's definitely not something I'm going to be redoing on this car. These are set in stone. This is what it gets. But for the next set and for all future sets, I learned quite a bit, which is awesome. So thank you, Zach, for giving me the opportunity to make them on your car, because it did teach me a lot, and they are a really, really quality piece. If they get ceramic coated, they're pretty much going to be a lifelong 3-valve turbo header. We got the rest of it in. I got the mid plates, tabs tacked in there on the backside, and this side I got front, back, and bottom. So I can pull this out tomorrow and fully weld that in. But before I pull this out for no reason, I'm going to measure all the pieces that I want to add to beef up this mounting location. I'll get those laser plasma cut in the morning, and then I will take it out and box that all in how I want it on both sides, fully weld the rear ones. I don't think I'm going to really add anything to that. And then I'm going to start keeping in mind, we got to put a starter in, but I need to put some kind of tie rod somewhere on this apparatus for fore and aft movement. So I'll probably, I don't know, maybe do something from the frame rail to one of the header bolts. I see there's like a big boss up there. I'm not sure where that goes to, but maybe I could put a tie rod into that. I just want something to really stop it from going back and forth, because it does still have a rubber trans mount. So really, if we tried, I'm sure we could get this thing to move back and forth on the aluminum plates. Steering shaft clears with tons of clearance. I'm just leaving it out because the motor's going to come in and out 5 more times. But anyway, that is going to wrap up this project for now. We have a bunch of cool products coming forward that we're going to be able to use, stuff that we have not used before. So I'm pretty pumped. Look, you can even see those are really, really close. The 2 outputs are even with that bar. So really excited to use a bunch of products that are cool and on the market today that we don't really use in streetcar stuff. So pumped, really excited. So anyway, make sure you subscribe down below, guys. If you haven't checked out the last couple videos on this car, do so, because this is going to be one badass Shelby GT, and we'll see you guys in the upcoming episodes.